So the second part of the inorganic practical was coordination chemistry. Much smaller data sheet. We're just going to take 5 different transition metal ions and look at them in various ways. I'm going to say right up front now that the first 3.5 days we didn't actually have any good Fe2+. I will talk about that as we go through. So here is the right stuff for the Fe2+. Anyway, first set we're going to look at is what's the color of these ions in water. If we just take solutions of copper or cobalt chloride, copper chloride, iron chloride or iron nitrate or iron sulfate or iron chloride or chromium chloride, chromium nitrate and so on, then we will see essentially colored solutions in water. Cobalt is that lovely pink. The copper we've already talked about in the previous movies, nice light blue. Iron 2+, it's sort of a greeny yellow color. I put it here in the volumetric flask that we made up rather than a test tube just to really emphasize it looks yellow, but it's more of a greeny yellow. Fe3+, that lovely orangey brown, and then chromium 3+. Now, this is one where you can get a little bit confused with things depending upon which chromium ion you take. This is chromium nitrate. It is this deep blue color, right? Hopefully you can see the deep blue. Some people call it purple. It's actually a deep blue color, but you know, we're not going to fight over semantics there. Now, in all cases, this color is due to the octahedral metal complex that has 6 water molecules around it. Okay, so M, general metal, M for metal, 6 waters, and I've said N plus because the cobalt, the copper, and the iron 2, N would be 2, so they're all 2 plus for the iron and the chromium, iron 3 and the chromium 3, obviously it's a 3 plus cation. So anyway, you need to know these colors. These are the colors of the hexa-aquo metal cations, so the metal cations with 6 water molecules coordinated to them. Next thing we did was we reacted up these metal ions with hydroxides, okay? And in every case, you initially make the solid metal hydroxide, the insoluble metal hydroxide. Remember, the only hydroxides that are soluble are those of the alkali metals, of ammonium, and then of barium and strontium. Okay, so here's the first set of things. There is the cobalt hydroxide, that pretty pink cobalt that we added hydroxide to, and it gives a blue-green precipitate, kind of pretty there again. Tried to take these pictures as the precipitates were forming to give you an idea of it. Failed in some cases. Copper 2+, that nice pale blue solution, if you remember, makes a pale blue precipitate there. Fe2+, you get this sort of greenish, dirty green precipitate is a great way to talk about that. Fe3+, if you remember, had that nice sort of brownish solution. You make the reddish brown precipitate with that, and then chromium 3+, that was that nice dark blue solution. When you add in the hydroxide, you start making a greenish blue precipitate. It is green. The blue color is just from the dilution of that nice dark blue that we saw. So anyway, here are the hydroxides of all of these metal ions. And these are just their neutral species is just the metal ion again with the appropriate number of hydroxides there. You have water molecules coordinated and so on, but the crucial salient species is the metal with N hydroxides, where N is 2 for cobalt 2+, copper 2+, Fe2+, and N is 3 for Fe3+, and Cr 3+. And here is the reaction that forms those, if you can handle with all the nasty little ends floating around the place.